so today we're going to be solving equations with variables on both sides. So I'm going to start out like we did last week. I'm going to give you a problem that's solved, and we're going to justify each step. So example 1, my directions are going to be to justify each step. All right. So I'm going to give you the equation 3x plus 5 equals negative 2x plus 15. So notice this is where that with variables on both sides come in. So you have an x, 3x on the left, negative 2x on the right. Remember last week we had a variable just on one side. All right, and I'm going to give you all of the steps to solving this equation, and what we're going to do is we're going to go back and justify what did they do to get it. So then I have 5x plus 5 equals 15. Ooh, yes. And we're going to talk about why it changed. Perfect. And I have 5x equals 10 and x equals 2. So I'm going to give you all a chance to write that down, and we're going to talk about what happened to change that 3x to a 5x. So from the given equation to the second line, we have 3x plus 5, and that changes to 5x plus 5. And I had negative 2x plus 15, and that changes to just 15. So what did they do from the first line to the second line? What do we got? Perfect. They added, right? So they added 2x to 3x to get 5. And they added 2x to negative 2x for it to cancel. Perfect. So add 2x to both sides. Perfect. I have a skeptical look. Is that okay? This time? All right. So then from the second line to the third line, I go from 5x plus 5 to just 5x. And on the right side, I go from 15 to 10. So what happened? Subtracted 5. Beautiful. So subtract 5. All right, and finally, from the third line to the fourth line, I go from 5x to just x, and from 10 to 2. So what happens? Perfect. We're going to divide both sides by 5. All right, so I'm going to give you an equation like this. I'm going to give you about 2 minutes, and I want you to justify each step. You can talk with your groups, and then we're going to come back together and compare our answers. I'm going to call this one 1B. And this equation is 9x minus 2 equals negative 6x plus 43. And I have 15x minus 2 equals 43. 15x equals 45. X equals 3. So just like the first example, I want you to write down the steps. What happened so that you could write each new line. Good conversation. Very good. I'm going to give us about 30 seconds, then we're going to discuss this. All right. So to get from the very first line, that's our given equation, to the first step, if I look and compare on the left side, I go from 9x to 15x, and I kept my minus 2, right? And I also kept 43 on the right side, but I lost negative 6. So what happened to both sides so that both of my x's changed? Added 6. So I added 6x to both sides. Perfect. All right. And then from the second line to the third line, I changed from 15x minus 2 to just 15x. And 43 became 45. So what did I do to both sides to change? We added 2. Perfect. So I added the constant 2. And then, finally, we went from 15x to x and 45 to 3. So how did I change 15? How did we move that 15, that coefficient? We're going to divide both sides by 15, and 45 divided by 15 is 3. That's perfect. Exactly right.
How do you get 15 adding negative 16?
So 9 plus 6. Because we do the opposite. Hold on, let me finish writing my thought there. So here I'm adding 6x, right? Because that's the inverse. Very good question. Because you were thinking, well, we would add a negative 6, right? All right. So now I'm going to give us a problem, and we're going to solve it using all the steps. So from now on, my directions are going to be to solve for the variable. So I'm going to give us a problem. We're going to solve it together the first time, and then I'm going to give you an opportunity to solve one in your groups, and then we'll check it. The next problem, I'm going to use 4x minus 15 equals 17 minus 4x. And I gave us kind of a tricky one to start with. And something I've noticed a lot of you doing, and I think it's really clever, is you're drawing a line down the middle where the equal sign is. Great job. Keep doing it. Does it help if I do that too? And does it make a difference for some of us? I think it's really clever because it makes me remember which side's my left side and which side's my right side. It kind of gives me a better idea of where everything should be. All right. So to solve this problem, I'm going to be completely honest with you. I see 5 different things I could do first to solve for x. We could add 15 to both sides. I could subtract 4x from both sides. I could subtract 17 from both sides. We could add 4 to both sides. And the last one is confusing, and I'm not going to tell you. I've seen people do it, though. If it makes sense and you're doing it, we'll have that conversation. Otherwise, I'm not going to show you because it's kind of crazy. All right. So any of those 4 ways that we just talked about, you can do and still be correct. I'm going to model for you, you guys, the method that is most of the time the quickest way. Right? Because when these problems, when it takes you a lot of space to solve a problem, how many of you get discouraged when you're like, it's taking a lot of space, I must be doing it wrong? I do that all the time. right? So what I'm going to do is I want to show you, because some of them do take a lot of space, it's a lot of steps. Not always, but sometimes. So I'm going to show you what I think is the easiest way, okay? If you prefer a different method, go for it. But this is what I'm going to do every time. You ready? So what I'm going to do is I always look at my equation. I see, okay, I've got an x on the left side, I've got an x on the right side. I ask myself, which one is smaller? -4, perfect, on the right side is smaller than +4, right? So what I do is I find that smaller one and I decide I'm going to move the smaller one first. Why would I want to move the smaller x first? Well, what if I had subtracted 4x instead of added 4x? What if I had subtracted 4x from both sides? What's it going to give me? A negative number, right? And negative numbers aren't always nice, right? Sometimes they can be kind of mean and ugly, especially if we have to divide later and forget the negative, right? That happens. So I'm always going to find the smaller x first and move it. Are we wrong if we do it the other way? No. But I'm trying, if at all possible, to eliminate any mistakes we could make. Okay? So that's what I'm going to do. I'm going to add, I'm going to do the inverse and add 4x to both sides of my equation. So on the right side, -4x plus 4x cancels, right? That's going to leave me with 4x plus 4x is perfect. Minus 15 equals exactly. So now I've got all of my x's on the left side, so let's try to move all the numbers to the right. What do we got?
15,
Exactly.
17,
Exactly. So if I add 15 to both sides, I get 32 on the right side. Oh, I changed back. There we go. Equals 8x. Beautiful teamwork, gentlemen. All right, and finally, how do I get rid of that coefficient? Divide both sides by 8. So then I've got x equals 4. Very nice. All right. I'm going to give you one like this to try on your own. Let's do, that's a good one. Going to give us, we've got 10x minus 22 equals 29 minus 7x. So I'm going to give you guys about 2 minutes. I want you to solve this. Use your group. Discuss. Check with one another. Use insult to check if you would like. I'm going to give us about 2 minutes, then we're going to review it. What's up? Yeah. I'm going to give us about 20 more seconds, and we're going to review this one together. Table E's got it. Table D's got it. How's Table B doing? Beautiful. You got it. Perfect. It's going to be okay. Table A's got it. All right. I have a few pencils still moving. That's okay. I'll start out talking slow. Y'all ready? All right. So I've got 10x minus 22 equals 29 minus 7x. So which x is smaller? The 10x, the minus 7x, right? So I'm going to do the inverse and add 7 to both sides. Add 7x. So that my 7x's cancel on the right side. All right. So then 10x and 7x is perfect. Beautiful. And then to move that minus 22, what's the inverse of subtracting 22? Add 22 to both sides. Very good. So I'm left with 17x equals 51. So finally, I'm going to divide both sides by that coefficient 17. So x equals, very good, x equals 3. All right, so what we're going to do now is I'm going to take this idea of having an x on both sides, and I'm going to add one of the steps we did last week. So remember last week we talked about solving equations with a variable on one side, multi-step equations. And then I added a couple of those steps because we started with 2-step and I added some steps. So I'm going to add a couple of steps. Y'all ready? Just like we did last week. So we're going to have combining like terms and distributing. All right, so let's start. Does everyone have example 3? All right. Example 4. I have negative x plus 7 minus 6x equals 19 minus 3x. All right, so which step from last week did I add? We have to combine like terms. Beautiful. So where are my like terms? Negative x and negative 6x. What about negative 3x? It's a like term, but why am I not going to include it again? Because it's on the right side. It's not on the same side, right? Perfect. So they've got to be on the same side of the equal sign. So negative 1 minus 6x gives me negative 7x. Good teamwork, gentlemen. So I have negative 7x plus 7 equals 19 minus 3x. So now, that's just like we were doing, so I added just one more step, right? So I'm going to look to see, so I've got an x on both sides of my equation. So which is smaller, negative 7x or negative 3x? Ooh. All right, and this is how, it is negative 7x, and this is how I remember. So I was actually out in my yard this weekend doing some yard work, and I was digging some holes. I was planting stuff. And if I dug a hole that was 3 shovels of dirt deep, right? And I dug a hole that was 7 shovels of dirt deep. So I would have gone down 3 shovels. I would have gone down 7 shovels. And I had someone in first period say something kind of clever. He goes, but what if you used a different shovel? Right? It's a valid point. But then I pointed out, I was like, but each shovel was X. So I used the same shovel. Hey, look at that. So which hole would be deeper? The 7, right? So that one's further down. So when I think of positive and negative numbers, I think of positive as being up, negative as being down, right? So negative 7 is smaller. Does that help a little bit? That's just one way to think of it. I'll have more analogies. So what I'm going to do, I'm going to move that negative 7x. So what's the inverse of minus 7x? Plus 7x. Perfect. So I'm going to add 7x's to both sides of my equation. They're going to cancel on the left side. So I have 7 equals 19 plus 4x. So then I want to move 19, so I'm going to do the inverse and subtract. Is that okay? Have I lost anyone? No? A little bit?
I added negative x plus negative 6x plus
But see how we drew the line? You've got to leave the like terms are only on the same side of the equal sign. It's a very good point. I'm so glad you brought that up. So when we combine like terms, your variables have to be on the same side of the equal sign. Very good. All right, so then I can simplify. So 7 minus 19 is negative 12. Perfect. Equals, and I'm left with just 4x on the right. So then how do I get rid of that coefficient? Divide. So if I divide both sides by 4, negative 3 equals x. Or if we want x to be first, I could say x equals negative 3, right? Fantastic. All right, I'm going to give you guys one like this to try. So I have r minus 4 plus 6r equals 3 plus 8r. Ger? Yes. There's r's. It's not that bad. I'm going to give you all 2 minutes. I want you to work with your group. Talk about it. Check each other's answers. Use Insolve if you would like at the end to check. And then we're going to go over it together. On the same side. But remember last week when we didn't combine like terms to begin with? Like if you kept moving them, you could still get to the same answer. But it's easiest if you combine them first. Positive, because you're going to look at the sign in front of it. Good question. Very good. You got the first step. That's the hardest one. All right, you guys, about 15 seconds, then we're going to come back together and check this one. We've got a couple of really good questions. You got it. You got it. That's right. That's exactly right. So then what's the inverse of positive 7r?
negative 7r.
So you're going to subtract 7r from both sides. Perfect.
So we don't. So For the first step, we don't do it on both sides, but for the second step, we do.
There you go.
Okay.
So when we combine, because that first step was to combine like terms, right? So when we combine like terms, it's everything that's on the same side. And then when we start moving, that's when we're doing it in the inverse operations. Perfect. You got it. Very nice. There you go. There you go. All right. Let's take a quick look at this one, you guys. I see a few pencils still moving, but I think most of us are close to that last step. So I'm going to start with my line. So do I have any like terms to combine? Yes. R and 6R. So I had a question. Is that R positive or negative? Positive. But that negative after it, is it easy to confuse it and think it's negative? Yes. So be careful because we're looking at just the sign in front. So 1R and 6R are 7Rs. That's kind of confusing. A-R-E, Rs. Huh? Sorry. There. How about that? I'll say they are. They're 7R. So then I've got minus 4 equals 3 plus 8R. Very, very nice. So then I'm going to look at both sides of my equation. I have an unknown on both sides. So which one's smaller, 7R or 8R? 7R. So I'm going to move that one first. So the inverse of 7R is minus 7R. Perfect. So minus 7R. So 7R minus 7R cancel. So I have negative 4 on the left side. So be sure you bring that sign down with it. It's easy to leave it behind, right? Be sure you bring that sign down. Equals 3. Then 8R minus 7R is 1R. Perfect. Finally, I need to move that 3. So the inverse of 3 is negative 3. So I'm going to say minus 3 on both sides. So that gives me negative 4 minus 3 is negative 7 equals R. Or I could say R equals negative 7. Because I know some of us like to have that variable on the left. All right. 2 more examples. 2 more examples. So example 6 says 3 times 3a minus 2 equals 3/4 times 4 minus 24a. It's just a fraction. I know the fractions, bless you. I know the fractions give you a little bit of anxiety. No worries. Just a little bit. That's okay. It's good to be taken out of your comfort zone every once in a while. Well, here's the thing. You can use your calculators. We need to use your calculator to multiply. So, to solve this equation, what do we have to do first? Distribute. Perfect. So we're going to distribute 3 on the left side. So 3 times 3a, perfect, is 9a. And 3 times negative 2 is negative 6. Equals 3/4 times 4. So if you're having a lot of anxiety, use your calculator. That's okay. So 3/4 times 4. 3/4 times 4 is 3. And then 3/4 times negative 24a. So we're going to multiply the coefficient first. So negative 24 times 3/4 is negative 18. And don't forget your variable a. Yes, ma'am.
How did you get 3?
Very good question. So 3/4 times 3, I saw a lot of people just type it into their calculator. But if you did this, 3 times 4 is 12. 12 divided by 4 is 3. So if you multiply, if you have a whole number times a fraction, if you multiply it to the numerator and then divide, or simplify, whichever is better. 12 divided by 4 is 3. And then the same thing here, 3 times negative 24 is, it's a big number. And then divided by 4. So actually what I did was I simplified when I was multiplying. And then divided by 4 would give you negative 18. All right. So now I've got 9a minus 6 equals 3a minus 8. Sorry, 3 minus 18a. So I need to move my smaller unknown. So which one's smaller, 9a or negative 18a? Negative 18a, right? So I'm going to do the inverse and add 18a to both sides. So then 9a plus 18a is perfect. 27a minus 6 equals 3. And then, what should I move next? The 27 or the minus 6? Minus 6. So the inverse of minus 6 is positive 6. So I'm going to add 6 to both sides. So I have 27a equals 9. And then, but it's not 27 divided by 9. It's 9 divided by 27 gives me, 9 divided by 27 would be 1/3 or 0.3 repeating, or about 0.3 or 0.33. Oh, not always on the right side. You're going to divide by the coefficient of the unknown. Good question. You're going to divide by the coefficient of the unknown. All right. So let's do one more. I'm going to have you guys try one of these. One more. You got this. Piece of cake. All right. Let's do, what is this, example 7? I'm going to have 3x minus 2x equals negative 2 times 2x plus 2. I know, I kind of put everything together. It's everything we've done so far today together. I want y'all to try it. I'm going to give you about 2 minutes, and we're going to cover it together. While y'all are working on that, I'm going to hand out your homework for this week, but we're going to talk about that after this problem.
When is it due?
Wednesday. It's not due till Wednesday. It's only 5 problems. Again. Good. I'm glad you approve. Yes. Yes.
On this one, how would we 18 to both sides? I thought it was going to be 9 minus 18.
You could do that. We could have subtracted 9 from both sides, and that would have given us negative 27.
Does it really matter how we do it? We will end up with the same answer? Okay.
It would have, that one would have been the same amount of work, just you would have had to remember to divide by a negative. But we would have done the exact same answer and the exact same number of steps. Good question. Because 3x minus 2x is 1x. Mm-hmm. Thank you, sir. All right. Okay, pencil's still moving. I want to give you all another moment. All right, so I know some of you are still working it. Here on the left side, I've got 3x minus 2x. What can I do? Do we have like terms? Do we need to distribute? We have like terms, right? So 3x minus 2x is 1x equals. And then on the right side, I have negative 2 times 2x plus 2, so what can I do? What's that called when we multiply across the parentheses? Distribute. Beautiful. So negative 2 times 2x is, very good, negative 4x. And negative 2 times 2 is negative 4. All right. So then I'm going to move all of my x's to the same side. So which one's smaller, 1x or negative 4? Negative 4. So I'm going to add 4x to both sides. So I have 5x equals negative 4. And then divide by 5. So I get x equals negative 4/5. Or did anyone get the decimal? 0.8? Oh, nice. Very good. Beautifully done, you guys.